The first concept is exposure. Exposure is a measure of ionization produced in air by photons. By definition, it is the charge over mass. So charge has a unit of coulomb, mass has a unit of kilogram. So exposure has the unit of coulomb per kilogram. A more convenient concept or a more commonly used unit of exposure is called Röntgen. So Röntgen is also charge over kilogram, but with a one Röntgen is a lot smaller than 1 coulomb per kilogram. So in fact, one Röntgen equals 2.58 times 10 to the minus 4 coulomb per kilogram. That is a more commonly used special unit of exposure. So in radiation therapy, we don't hear exposure very often. And why is that? If exposure, that seems very convenient, why don't we just use it? So here's a diagram that basically discuss about how ionization is produced and measured if we go by the concept of exposure. So for example, a radiation X-ray beam comes into this measuring area circled by this yellow region, and then the beam produces ionization, so the ions and electrons get drawn by those electric plates and they form current, and that's basically how you measure exposure. So one important concept is called charge particle equilibrium. So basically what it means is that the electrons produced inside those collecting region can deposit not only the energy inside this region, but they can also exit out. They deposit the energy outside the region. So in order to measure the exposure, we need to have the charge particle equilibrium, CPE. Basically means what's generated inside equals what's generated outside. And why is CPE important? Because the concept of Röntgen is only valid when CPE is achieved, and this is from its definition. So there's a point that exposure breaks down. So for example, imagine if you have a more energetic beam, you produce a lot more ionization in here. So in order to fully account for the CPE, aka what's in equals what's out, you have to increase the separation of your two electric plates, meaning you have to increase your measuring volume. So there is a limit of a incoming photon beam. So if the beam energy is above 3 MeV, your plates, they are too far away from each other. They cannot hold a steady electric field that give you the current measurement. So if the limitation of the exposure is that if your energy is too high, and Röntgen cannot be accurately measured.